Hello students, welcome to AcadShala.
Learn from the past to live in the present so you can see your future. Yes, don't be the same, be better. But way to compare it? Not at all, children. You should never compare yourself with anyone. Rather, you should compare yourself with your past. That is, what are you working today? Compare it with your past when you worked. What is the difference? Is there any improvement in your work? That is a better way to improve in your work. That is, your main aim is today your studies. So today, children, we will be starting part 4 of Gravitation chapter.
But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel AcadShala. This gives us a lot of motivation to keep creating these kind of videos for you all.
Students, are you seeing a big question mark over here? Yes. That is, if we have two objects of same mass, why they are not colliding? A big question mark for this question, which has to be solved. So a big question mark is still there in the story, which has to be solved today. So today you are seeing on the screen a block in the center and the students on both the sides pulling the block. But to my surprise, what do I see? I see that the block is still at rest, no matter both the teams are pulling, but in opposite directions. But the block is not moving. Again, I'm saying it is in rest position. That means, what do I conclude into this? That is, the forces F1 over here and the second force F2 over here, that means they must be same. That is why F1 is equal to F2 and this indicates the block in the center is at rest. Okay, so what further I can conclude from here? That is balanced force. Body at rest, that is block at rest, means that is balanced force. Why balanced force? Because both the forces are equal but in opposite directions. Okay. Balanced force, if the block is at rest, that is same force applied, that is, or balanced force, but in opposite direction, that is, they will cancel out each other. Which forces? That is F1 and F2. So that means F1 force will cancel F2 force. And that is why this block in the center is at rest position. Okay. Now children, are you seeing something on the board? Yes, this is a boy. What this boy is doing? He has taken a piece of thread over here. Are you seeing it? So he has taken a piece of thread, tied a small stone or a ball at one end. Hold the other end of the thread and whirl it around. Are you seeing in the diagram over here? Yes. Note the position of the ball or a stone. It's moving in a circular path. So after noting the motion of the stone, what I do afterwards? I will release the thread. I left it. Again note the direction of the motion, where it will go. Yeah, this way it will go. Yes. Now, before the thread is released, the stone moves in a circular path, as you're seeing it over here, children, with a certain speed and changes direction at every point. See, over here, over here, over here, every position, it's changing its direction. Yes or no? That is why we are saying it is in circular path. The change in direction involves change in velocity. Yes, of course. We are watching over here. Velocity or acceleration? Yes, absolutely correct. The force that causes this acceleration and keeps the body moving along the circular path is acting towards the center over here. This force, which is in the center, that means boy's hand, is known as centripetal force. I repeat, centripetal force or center seeking force. I repeat the name of the force, centripetal force or center seeking force, which is in the middle of the circle. That means that is boy's hand. Okay. Now, what will happen in the absence of this force? When there is no centripetal force, that means when the boy releases the thread. So now what will happen? You can view this diagram also now. Next. In the absence of this force, that is centripetal force which was there in the center, the stone flies off. The stone flies off along the straight line. You are seeing in this diagram, children. Yes or no? In the center, it was a centripetal force. When this boy was whirling the thread, that is tied a stone or a ball at the end. When he released, then it went straight away like this because there was no force in the center. The force name was centripetal force. So there was no force called centripetal force because he released the thread. This boy released the thread along with the ball or a stone. So the stone flies off along a straight line. This straight line will be a tangent over here. Are you seeing the third diagram? So this straight line will be a tangent to the circular path. That means the boy, when released the thread, this stone, for example, stone or a ball, went over here at this position. Yes or no? The boy released the ball, that is released the thread, and the ball or the stone went straight away over here at this position. And then what happened? This straight line will be a tangent to the circular path like this. That means a straight line that meets the circle at one end, at one and only one point, is called a tangent to the circle. Straight line, that is ABC, is a tangent to the circle at point B. That means when the boy released the thread along with the ball or a stone, the stone came over here at this position, made a tangent and went straight away. So this is how this force which was here when it went straight away, that is along a circle, that means this centripetal force was not there. In the absence of this centripetal force, the centrifugal force was there. When we say that the tangent to the circle was formed, that means instead of centripetal force, there was no centripetal force at that particular time when the ball was going straight away. Apart from the circle, came out of the circle, the force applied was centrifugal force and there was no centripetal force. So overall, it is there In the center, the force applied is centripetal force. That means the boy is whirling the thread along with the ball or a stone. That means on his hand, centripetal force is there. But when he releases the thread, when it goes outside the circle, the centripetal force is not there. It is vanished. It is not there at all. And the force applied when it goes along the tangent outside the circle, the force was centrifugal force. Am I clear, children? So there are two forces, centripetal and centrifugal force. And you should also know what happens that the straight line that is a tangent to the circle. And this B point is when the boy released, the ball came at this point B, made a tangent, went straight away outside the circle, indicating that centrifugal force is now applied over there. And that is why it went straight away. So that means this is having the same magnitude but opposite direction. So now you have to remember two forces, centripetal force in the center, centrifugal force apart, along, that means outside the circle is centrifugal force. Inside, in the middle of the circle, it is a centripetal force. Yes, children? So please do revise. This is very important. In the next video, we will be studying about this also. A part of this also we will be studying in the next video. So till then, keep on revising, keep on sharing AcadShala link with your friend circle, keep on subscribing the channel also so that these kind of videos keep on coming in future too. So take care, children. Bye-bye. God bless.